Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be talking about the pH scale, and specifically we're going to be looking at acids and bases. All right, so you've all seen the pH scale before, and in case you don't know, the pH scale gets the H from hydrogen. So when you're looking at pH scales, you're looking at the amount of hydrogen ions that a certain substance has, but in reality, hydrogen ions don't just float around in water, they form hydronium ions, so H3O+. So the amount of H3O plus is directly related to the pH. Acids that have a pH less than 7 are going to be acids, and so they have pHs between, like it says, 0 to 7 here. Bases have pHs greater than 7, and neutral substances have pHs of exactly 7. So the way it works is neutral is exactly 7, and then pretty much everything from 0 to 6.99999 would be acidic. Everything a little bit after 7, so 7.0000001, all the way to 14, that would be a base. There are very few examples of things that are neutral. So there are very few things that actually are neutral and have a pH of 7 on the pH scale. Something common that people make a mistake on is the pH scale runs from 0 to 14, not from 1 to 14. 0 is actually the most acidic thing you can get. 14 is the most basic. So what properties do acids and bases have? Well, acids taste sour. That used to be the test that they would use, or one of the tests to figure out if something was acidic. You would take a little small dropper bottle and put a drop of it on your tongue. And if it was sour, then that meant that it was an acid. They also burn through metal, and they turn litmus paper red. So these are just some basic properties acids have. Bases taste bitter. They feel slippery. By the way, they don't burn through metal, but they still burn through skin. So strong bases are actually pretty hazardous to humans. And they turn litmus paper blue. In case you don't know what that means, litmus paper looks something like this. And when it turns red like this, that means it's an acid. When it turns blue like this, that means it's a base. Now, what happens when you mix acids and bases together? Well, there's a special type of reaction called a neutralization reaction. And that's because if you have the exact same amount of acid and the exact same amount of base, when you mix them together, they form a neutral solution, and so that is called neutralization. Now, when you make a neutral solution, what are you actually making? You actually make a salt and water. So water is, neutral, has a pH of 7, and then salt just means any ionic substance, really. So you're making an ionic substance, and that ionic substance, the most common one, is the one that you're aware of, sodium chloride, right? That would be an example of a salt, and that's what happens in a neutralization reaction. So write this down as our example. This is an example of a neutralization reaction. You have HCl, which is hydrochloric acid. We have NaOH, that's sodium hydroxide. And then when you mix them together, you get NaCl and you get water. So what do you notice about this? You've got Na and Cl pairing up, and then you've got these leftovers. You've got an H, an O, and an H. So two H's and an O, that's water. Okay, so if you were to look at this in picture form, it's a little bit more clear. You can see that we have this gigantic chlorine, this green thing, and this gigantic sodium that's purple. When you mix them together, you make your NaCl, that's salt. And then you can see that just a hydrogen pops off from this HCl and it attaches to this oxygen. And now you get H2O. Now, what's something else that we need to know? Some acids and bases are stronger than others. You have really strong acids and you have weak acids. You have really strong bases and you have weak bases. So what do strong acids and strong bases have in common? The first thing is the amount of electricity that they produce. So strong acids and strong bases conduct large amounts of electricity, and we call those strong electrolytes. So you're used to seeing the word electrolyte probably on a Gatorade bottle or something, and that's because electrolytes are important in conducting electricity, and that's what your brain uses and neurons in your brain use in order to send signals. So when we say it's a strong electrolyte, what we mean is that it breaks apart completely. So when you put it in water, the ions dissolve completely, and that's why they conduct electricity. So here's an example. You can see we have a conductivity tester with a little light bulb. The brighter the light bulb, the more electricity is being generated. And then you have just this little solution of strong acid. So the strong acid is so strong, all of its substance breaks apart into ions. You can see all these positive and negative charges, and that's what makes it a strong electrolyte, and that's what makes it such a good conductor of electricity. Now, strong acids generally have very low pHs between 0 to 2. Strong bases have very high pHs between 12 to 14. Remember, they are opposites. It's just they can both be strong. Strong bases, strong acids. What about weak acids and weak bases? Well, weak acids and bases still conduct electricity, they just don't conduct very much electricity. And so we call those weak electrolytes. They're like opposites. And the reason why they're so weak is because they don't break apart very much. So whereas strong electrolytes break apart completely into positives and negatives, the weak electrolyte, which you can see the light bulb isn't very bright, doesn't break up very much. You've got like 2 positives and 2 negatives, but most of the weak acid is sticking together. So it's not breaking apart completely like the strong electrolyte did. In fact, weak electrolytes only dissociate partially. So only about 1% of them actually break apart. Whereas for strong electrolytes, 100% of them break apart. Weak electrolytes, you normally only get about 1% breaking apart into ions. Why does the pH scale run from 0 to 14? So remember this equation, the self-ionization of water. It's what the Arrhenius definition was kind of based on for acids and bases. So in case you forgot, water will react with itself and form a hydronium ion and a hydroxide ion. What you need to know is that the concentration of H3O+, that's hydronium, and OH-, that's hydroxide, in pure water is always equal to 1.0 times 10 to the negative 14. And so that 14 is important here, this exponent. That's why pH has a maximum value of 14. If you take the negative logarithm of this and plug that into your calculator, you get the number 14, which is why the pH scale stops at 14. Now, this is the equation right here, so you can write this down. I color-coded it though. So you've got hydronium ion concentration multiplied by hydroxide ion concentration always equals 1.0 times 10 to the negative 14. So in water, these are equal and you get a neutral solution. Because remember, the pH scale has a neutrality here of 7. And so if you have 1 times 10 to the negative 7, times 1 times 10 to the negative 7, you get this. And that's what makes water neutral, because you have the same amount of this stuff and the same amount of that stuff. What if they're not in balance though? Because that's the only way they're balanced is if you have exactly that amount. So what if they're not in balance? H3O+, if that's greater, then you have an acidic solution because you have too much of this and not enough OH- to balance it out. What if you have too much OH and not enough H3O+ to balance it out? That's when you have a basic solution, okay? So that's how you make acids and bases. If you have too much of this, it's acidic. If you have too much of this, it's basic. And that is it. So if you have any questions, please let me know, and we'll move on to the rest of our acid-base stuff later.